Assalamu alaikum and very good afternoon, my dear students. Welcome to my channel Maths with Umar. And in this video, we are going to see the applications of properties of parallelogram and the concepts to prove the statements. And as you know, this chapter is grade 9 quadrilaterals CBSE. Okay, so let us go to the first to the problem which is given in the practice questions and concepts. It's exercise 8.1, question number 1. What is question number 1? If the diagonals of parallelogram are equal. So if diagonals of of parallelogram are equal, then what you are supposed to do? Then we have to show that it is a rectangle. Then show it is a rectangle. Okay, let us see. That means what is given here? If the diagonals of parallelogram are equal, that means what is given? Parallelogram is given and it is given that diagonals are equal. Okay, let us try to find out the solution. First, write what is given. So what is given? Given that A, B, C, D is a parallelogram. Is a parallelogram. Okay. So let me draw the figure. So A, B, C, D is a parallelogram. And we know that once ABCD is a parallelogram, so AB is parallel to CD and AD is parallel to CB, right? So now you have to show that it is a rectangle, and also when it is a parallelogram, AB equals CD and AD equals CB, right? And you have to show that it is a rectangle. So for rectangle, what is the difference between a parallelogram and a rectangle? So a rectangle is a parallelogram in which opposite sides are equal and also the angle between the adjacent sides is 90 degrees. So that means you need angles also. So that implies, according to properties of parallelogram, angle A equals angle C, and I believe this is useful. This will be useful. Okay, so let us write this as first equation and second equation. Now let us go. What you are supposed to prove? To prove ABCD is a rectangle. ABCD is a rectangle. Okay, now let us go to proof. See, when you are supposed to prove it is a rectangle, so that means you have to prove that these angles, it is 90 degrees, right? Because we already know that ABCD is a parallelogram. So we have to prove that the angle between the adjacent sides is 90 degrees. And also here, actually what is given? Diagonals of parallelogram are equal. So here I miss one point. What is this point? The point is that diagonals are equal. That means AC is equal to BD. So it is given AC is equal to BD. Let us take this as equation 3. Okay. Now since AC is equal to BD, now what you have to prove? You have to prove the angle between adjacent sides is 90 degrees. So let me take these two triangles where adjacent angles are included. So shall I take this triangle which is blue in color? Are you able to see this? What is this triangle? This is triangle ADC. So in triangle ADC, and what is the other triangle? Let me take B, C and D. Okay, where this one. So in triangle BCD. So what are the parts which are equal? AD is equal to BC. AD is equal to BC. AD is equal to BC. Why? AD is equal to BC. From one, opposite sides are equal in a parallelogram. And after that, what are equal? It is given that AC is equal to BD. And AC is equal to BD. How can you find out? From second, understood? From, sorry, not second, third. Okay, because diagonals are equal, it has been given. And what is this? Is this the common side for both the triangles? Yes. So what is this? In this first one, it is DC is equal to CD and it is common. So if we take any one triangle, AD is this side, AC is another side, and DC is third side. So that means by SSS congruency criteria, triangle ADC is congruent to triangle BCD. Okay, now by CPCT, what we have to prove? You have to remember what to prove. ABCD is a rectangle. For that, I have to prove that these two angles are, the adjacent angles are, the angle between the adjacent sides is 90 degrees. So come on, take it by CPCT. In these two triangles, what do you say about angle D and angle C? Okay, angle D and angle C. That means angle ADC is equal to angle BCD. Okay, by CPCT. But we already know what are these two angles? Adjacent angles, right? So we have seen in properties that sum of adjacent angles is equal to 180 degrees. Now, we know that angle ADC plus angle BCD is equal to 180 degrees. Why? Adjacent angles are supplementary in parallelogram, are supplementary. Okay, so now since BCD, can you write it as ADC? Yes sir, ADC plus ADC is equal to 180 degrees. So that implies 2 angle ADC is equal to 180. So implies angle ADC is equal to 90 degrees. 180 divided by 2 is 90 degrees. So that is equal to angle BCD. So since these two angles are 90, these two angles are 90. So therefore ABCD is a rectangle. Got it, my dear students? So this is how we have to prove it. So please go through it and practice. Okay, important problem. Let us go to the second problem. So in this problem, in the second problem, it has been given. Yeah, before starting second problem, let me please remind you, since explanation may be little bit slow, so watch this video in 1.25 speed. Okay, so it is given in parallelogram ABCD. P and Q are points on the diagonal where P is here and Q is here. Okay, such that DP is equal to DQ. Where is it DP? Yeah, DP. Okay, I have written it wrong. Okay, so here it is P and Q. So they are telling that DP is equal to PQ. Okay, fine. These two are equal. And after that, show that triangle APD. Where is APD, my dear students? So this is triangle APD. Okay, triangle APD is congruent to triangle CQB. Okay, so let us write what is given, and so let us go to the solution. Given ABCD is a parallelogram. Okay, so once it is parallelogram, what we have to keep it in mind, that AB is equal to CD, and after that BC is equal to DA. Is it right? Let us take it as first equation. Now, what do we have to prove? A triangle APD is congruent to triangle CQB. So what did I tell you? If they are asking us to prove congruency, take those two triangles. In triangle APD and triangle CQB. Okay, what are the parts which are equal here? Let us see. APD. Okay, in this one, are these two opposite sides of a parallelogram? So that means AD is equal to CB. What is the reason? From first equation. Opposite sides of an parallelogram are equal. Okay, after that, they have given BQ is equal to DP. They have given, right? So they have given DP is equal to BQ. So let us write the same. DP is equal to BQ. Don't forget the order. So it is given. After that, see, they didn't give anything about CQ and AP, right? So we cannot use SSS congruency. And if we cannot use it, what others we can use? Let us go for angles. Since these two sides, try with these angles. Are these two angles equal? Yes, sir, these two angles are equal. Why? Because AD and BC are parallel, because sides of parallelogram. And what do you say about this line? The line intersecting two parallel lines or two lines is called as a transversal. Is it right? So if this is transversal, what are these two angles? These two angles are alternate interior angles, and alternate interior angles are equal. So what is this angle? ADP. ADP is equal to, what is this angle? CBQ, right? CBQ. Angle ADP is equal to angle CBQ. So alternate interior angles are equal. Try to write full form in examination. Okay. So now let us see AD and DP and this angle. So will they form SAS congruency? So by side angle is included. Congruency criteria. Triangle APD is congruent to triangle CQB. So then, since these two are congruent, so we have proved that these two are congruent, right? So now let us see what is the second thing you have to prove. It's prayer time. I'll go to prayer and come back. Okay? Wait. Yes, my dear students. And now, what is the second thing to prove? He is asking to prove AP is equal to CQ. So, where is AP? AP is this, and CQ is this line. And you can see that already we have proved that these two triangles are congruent. So, what are AP and CQ? These are the corresponding parts of these two congruent triangles, right? So, by CPCT, we can prove that AP is equal to CQ. Okay, now let us see what is the third one. The third one is triangle AQB. Triangle AQB is congruent to triangle CPD. Okay, now let us see where is AQB. A, Q and B. So he is talking about this triangle, and also CPD. Where is CPD? CPD. That means he is talking about these two triangles. You have to prove that these two triangles are congruent. So already we know what we know. These are the AB and CD and DC or CD are opposite sides of parallelogram. They are equal. So AB is equal to CD. Follow the order. What is the reason? From 1, opposite sides are equal in a parallelogram. And next, what is equal? What do you say? What do you say about BQ? Yeah, it is given, right? BQ is equal to DP. So BQ is equal to DP. So given. Now these two sides are equal, okay? These two sides are equal. Now we don't know about third side. So what should we take? What shall we take? Let us take the angles. See, we know about AB and CD. Are these two parallel? Yes, sir. It is a parallelogram. Now, now if I join these two lines, these 2 points. So AC. What is AC? AC is what? No, wait. No. See, okay, these two are parallel, AB and CD. And what is this? It is a transversal. So actually we are talking about this angle, these two angles, right? So let us take BD as transversal. So what will happen? These two angles are alternate interior angles. So angle ABD is the ABD. ABD means you can write it as Q, right? Because we are talking about this angle, okay? And also CDB actually. Can you write P? CDP. So angle CDP. What is the reason? Alternate interior angles are equal. Now let us see AB, and after that BQ, and here it is BQ. After that DP, it is. After that this angle. So side and included angle and side. So by SAS congruency, triangle AQB is congruent to triangle CPD. Okay, it is proved. So what is the fourth point? So fourth point is what he is asking us to prove. AQ is equal to CP. AQ is equal to CP. So where is AQ? This is AQ. And where is CP? And this is CP. Just now we have proved that these two triangles are congruent. So by corresponding parts of congruent triangles, AQ is equal to CP. Right. And after that, the fifth one, what he is telling? APCQ is a parallelogram. It is a parallelogram. Where is APCQ? A, P, C and Q. You have to prove the innermost one as a parallelogram. Now, that means the innermost one, okay? So APCQ, if you have to prove a parallelogram, so you don't know whether they are parallel or not. But from second and fourth, from second and fourth, we have proved that AP is equal to CQ, and after that, what is fourth? AQ is equal to CP. Is it right? So AP is equal to CQ and AQ is equal to CP. This we have proved. So that means opposite sides are equal. So by the converse of 8.2, by converse of theorem 8.2. What is theorem? Converse of theorem 8.2. That means 8.3. What is it? If both pairs of opposite sides are equal, then it is a parallelogram. So APCQ is a parallelogram. What is the reason? Since if opposite sides are equal, it is a parallelogram. It is a Parallelogram. Understood, my dear students? See, try to understand what is given and what to find. Okay, so next let us see in the third video, which I am going to make not now, by night. Okay, because I have important work. So in the third video, I'll explain you about midpoint theorem and the remaining exercise problems which I have given in the practice questions worksheet. Okay, take care and please keep on practicing surface areas and volumes. And what is the other chapter? The other chapter was Heron's formula. So please practice those two chapters until you get the next video. Oops. Okay, so please watch in 1.25 speed if you and pause it whenever it is necessary and practice by your own twice or thrice. Okay, take care. Bye.